Calculus, limits. So here's a question for you, and it's a very basic question, but we need to understand some fundamentals here. Explain why the limit does not exist for the following functions. So we have a set of 4 here, and limit does not exist for all 4 of them. You need to give reasons for that. Okay. A. Limit of minus 1 to the power of x as x approaches infinity. Think and write your answer. B. Limit of x cubed plus 3 divided by x squared plus 1 when x approaches infinity. Limit of absolute x divided by x when x approaches 0. And limit of square root of 16 minus x squared when x approaches 4. So think about it and write down your answers. Here is how I will answer them. Now if you see the first one, which is limit of minus 1 to the power of x where x approaches infinity. Well, infinity is a very large number, but we don't know whether it is even or odd, correct? Minus 1 to the power of even number is going to be plus 1, and minus 1 to the power of odd number is going to be minus 1. So we aren't really sure. Therefore, the limit does not exist, correct? However, if we have a problem saying limit x approaches infinity for 1 to the power of x, in that case, what is going to be the answer? The answer is going to be 1, since 1 to the power of anything, howsoever large it may be, positive or negative, even or odd, it is going to be 1. So limit of 1 to the power of x do exist, and it is 1. So I am giving you added information here, since I want you to understand what limits is and when it can exist, when it cannot exist, right? Part B is limit of x cubed plus 3 divided by x squared plus 1. It does not exist. Reason is that if I divide both numerator and denominator by x squared, then what do I get? Let me show you. I get limit x approaches infinity, and if I divide by x squared, I get x here plus 3 over x squared divided by x squared divided by x squared is 1 plus 1 over x squared, correct? Now if x is very large, then what happens? If x is very large, then 3 over x squared will tend to 0, 1 over x squared will also be 0, right? 1 divided by a very large number. And so this will approach x. As x approaches infinity, the function approaches infinity, and infinity is not defined, correct? Therefore, it does not exist, correct? So that is the reason why it does not exist. Now, if I had, instead of x squared, x cubed, if I had x squared, then it will exist, right? Also remember that horizontal asymptote is kind of a limit when x approaches infinity, right? So if the degrees are same, then the limit will exist. Limit will also exist if degree of numerator is lower. So the limit will also exist if degree of numerator is lower than that of denominator, correct? So, but if degree of numerator is higher than that of denominator, then in rational functions, limit will not exist, correct? So that's the point to be noted, correct? Now, part C. So here we have an absolute function, and we're saying absolute x divided by x when x approaches 0, this limit does not exist. What is the reason? Well, the reason is that how do we define absolute x? Absolute x is actually equals to plus x if x is greater than or equal to 0, right? And it's a negative of x if x is less than 0. What I'm trying to say is, if you put minus 3 here, then the answer is plus 3, negative of minus 3. But if you put plus 5 here, then absolute x is plus 5, same as the x value. Now, that means that on the right side of, now let me write down, think like this. Think like this. So we are trying to check limit on both sides of 0. On the right side of x, this limit becomes x over x, correct? Which is 1. And on the left side, that means limit when x is approaching from the negative side, it becomes absolute x is minus x over x, which is minus 1. Do you see that? And therefore, limit does not exist. Since as we approach from the right side, we are approaching 1. And when we approach from left side, we are approaching minus 1. Since both the values are not same, limit does not exist, correct? If I have to graph it, then the function absolute x over x could be graphed like this. A hole here. Do you see that? Now, you can see very clearly from this graph that when you approach 0 from right side, you're approaching 1. And if you approach 0 from left side, you're approaching minus 1. And that is the reason that the limit of this function does not exist as x approaches 0, correct? Now let's look into part D. Limit of square root of 16 minus x squared when x approaches 4. Now, what is this function? Can you tell me? This function is a semicircle. Since it is just plus values, not minus, otherwise it would have been a full circle, correct? Now this is a semicircle where the x values are between minus 4 and plus 4, right? This is also 4. Now, limit at x equals to, as x approaches 4. As you can see, the domain of this semicircle is restricted. X cannot be more than 4, and therefore you cannot approach from the right side. So we say limit for x when you approach 4 from plus side, that means the right side does not exist. Let me write f of x for this function does not exist, correct? Since that is not in the domain of the function, correct? If I write anything more than 4 here, then within the square root, I'm going to get a negative thing. And square root of a negative number is imaginary, is not real. So we are not approaching a real value. That is why the limit does not exist. So this is a very important question. I hope you understand and appreciate it. Thank you and all the best.